Actually, that's now the new metric. So how many boards do you need to compute your Merkle tree? It's going to be the new depth.
By 2 weeks, we'll optimize one board.
Is it started?
Yeah.
Yeah. Okay.
It's
So
very informal.
I'm gonna reintroduce the discussion. So, yeah. So early April, you sent me like the paper, the thing you wrote about totem, which at the time to me was more like, okay, how we can resolve like identities or proof of identities coming from different data points. Us, like in the meantime, we were like thinking about how we can make a lighter way to consume proof of identities issued by our protocol. And then when we thought about what we wanted to work on, like during the residency, we were more like, okay, so SSO is cool, but what we can do, like build something that where we can aggregate more proof to it. So we thought about semaphore, and in our case also semaphore is cool because it, in one of the flow of the way we designed the identity protocols is that you have like one main identifier, and so even if you have like a seed, someone can replay the seed and track your activity, for example. So having a level of abstraction on top of it and using semaphore for it was like a nice idea. So how we want like to framework it. So at first you need to like to create a semaphore identity. So you have two options. You can have like either like a deterministic identity or random identity. So we don't want to go with deterministic because it's very hard to. So let's say that you want to have something deterministic that is common to your identity. So let's say you compute like an unifier in proof of passport, we compute an unifier in an anonada, and let's say that we want to use that. So the mechanism of an unifier is quite weak because someone can like replay. So in our case, just to introduce that notion, so the unifier in anonada is the hash of a seed, a unifier seed, which you can think of like an application ID, which is up to the third party to set. So you have a seed and you have like the photo bag. Okay. So let's say that you want to use that as a deterministic way to build the semaphore ID. If someone like just take a seed and replay the seed and compute your nullifier, like they can like basically store pre-compute all the semaphore ID possible from anonada, and then like once you get logged in and you use your new semaphore ID, they can like just connect to it and like store all your data. So we don't want this, and so the semaphore ID. So after the process, you will have like a public key and a secret key. So for UX-wise, what we want to do is that this secret key can be like stored in the keychain. So that's another ID like stated like in totem. Okay, so that's the first part. Is that the way we create like a new identity. So then after that, what you want to do. So it's something that we discussed, but in my mind you have like several types of proofs, and to me it's like more something like where the base should always be like something like that is ID linked, so either like POP or anonada or Mina, for example. Then you have like a second layer which can be like a ZK email or a cursive, for example. And then you have like this can be seen as all the activities that you will do with your new identity. And why I rank them like that is because it's first like in terms of trusted assumption. So the trust assumption about like this signature is like quite strong because it's government, and like making the assumption that government will sign like fake identities is like it's a bit quite impossible, or at least it can happen, but in this case it's going to be like in terms of geopolitics a very a very big deal. And then here like it's also more trusted issuers, but not as trusted as this one. Yeah, so to me like the base of the identity should could always be like this kind of proof, or if you find an alternate way to prove humanity, like for example, WordPress, like they have like levels, and so for example, like the lowest level is just a proof that you have a YouTube account and a Discord account, for example. So you can think about something like that if it gives like the same security as the other ones. Yeah, so once you do that, so you get another proof. So let's say another proof. And so now you have like a proof of personhood, and you have like the output of the proof is like a unifier, which will be like a new kind of identifier. So now the goal of all of this is that, okay, so how do you link them both? So you can create like a semaphore group. And so this semaphore group will be like the verifier of this proof, and will have the role of maintaining the state. So the state is, as in semaphore, is a Merkle tree. And so here, you will have an add method, and prove method. Okay, so the group is responsible for both like verifying the group proof. So in this case, like for example, in Anonada, it's going to be like a group verifying your Anonada identity, and manage the state. So for the group, you have like two options. You can like have like a private server, or you can like have them on chain, or off chain, or off chain. So for us, like we prefer to have them like on chain, because this way is available, and we don't have like to maintain any server storing all the state of these groups. So yeah, so the flow is that, okay, so user want to sign up. In the background, creation of a semaphore ID, creation of an identity, proof of personhood proof, then joining the group. So in this case, the group would be like the Anonada group. So you give your proof, and then you're added to the proof. So then the first step is like, okay, so a third party want to consume, let's say, Anonada proof, or like have like to connect, you need like one proof of personhood plus one proof of Gmail account, or YouTube account, or Discord account, whatever. So then in this case, you can like create rules where you say, okay, to verify a user, I want like this kind, all the set of all these proofs. And so what is going to happen is just that we'll have like one service, which will be like a client, a front end, which here will go in our IDs like the AFK app in this case. So this front end will be responsible to fetch all the group membership, generate the semaphore proofs, and sell them to the client that want to use signing with AFK. And so the answer will be in the form of the semaphore nullifier, the public key, and the semaphore proofs. So no, sorry, I said the public key, but no, it's the semaphore nullifier. Yeah, so that's pretty much where we are at. So in this flow, there are like some flows. So especially, as you said, the problem is that as I'm committing to like the nullifier to the contract, and in the contract, you can get a link through my public key of my semaphore identity, so you can create a link. So that's why I guess in the totem article you have the idea of about like having like this big wall state stored in a Merkle tree, where you have like at itleaf a kind of ID, which in this case could be like the group ID, and the proof. the inclusion, the proof of inclusion from the underlying Merkle tree.
Okay, so that's pretty clear. So this is I think what you guys are doing are like quite like you're like more working on. I mean, I think this is like quite separate from Totem, and both can be like also used like at the same time. It's not for the same things. You're just like mostly trying to make it easier to consume the proofs, right? Like with an SSO. And Totem is basically, it's quite simple. It's like not very crazy. It's just basically using semaphore, but on top of semaphore, being able to do proofs of matching between different like attestations and attributes with like circuits, or just like finding that names are similar. But it could completely be like integrated in this type of SSO, I guess. Yeah.
What do you use semaphore though?
We could use the circuits from semaphore.
Yeah, because it's
In
quite
the end,
different.
semaphore is just like inclusion proofs of in Merkle trees.
Oh, okay. So last time I checked, so it was like you have two proofs, maybe like passport and then one email proof. Right?
Yes.
And then you are proving that the naming both is same.
Yes.
And the trick is like you use the same salt and output that. And
Yeah.
like if
That was the first prototype, but it's not like the final
okay.
design now.
I see.
But yeah, I mean, I think doing that is it's nice. So like
one point like here is the idea is like you use your proof of other or some identity system to join a semaphore group or to join multiple semaphore groups.
Yeah, it's very similar to what we want to do.
Yeah, the good thing is like when you want to prove your attributes, you only need to do this membership proof.
Yes.
Which is much cheaper than the other proof.
Exactly.
Also better UX, I think.
Yeah, it's exactly the same thing for us because before we just had one circuit that checks the passport. But for instance, if you mint an SBT, now you show like you link the nullifier of the passport with your address, right? And like because there's only one step. But if you do it in two steps, first you join this semaphore group, and you don't have to do it with your own address, right? You just register the secret, like semaphore secret, semaphore private key, and then you prove that you have a valid attestation in this group and mint your SBT. And you can do it like 3 days later.